Hey guys, how's it going? So, today is going to be Wednesday. Um, I have one more thing that I need to teach you about stoichiometry, and that is something called percent yield. Uh, get that out of here. So, percent yield. How do you figure out percent yield? Um, so here's the dirty secret about chemistry is that we're going through and we're using stoichiometry to figure out like how many sandwiches we're getting, right? How much hydrochloric acid are we getting out of this? If I have this many grams of you know, potassium, or I'm sorry, geez, phosphorus, pentachloride, and water, how much hydrochloric acid are we going to be getting out of it? Here's the thing, though. None of these reactions work 100%. There's always going to be, some byproducts, maybe some things that don't actually work out. So um, there's something we need to figure out what percent of our theoretical that we are actually getting. So the first bit of this is just like what we did before. We have ourselves a balanced reaction. We need to figure out what our limiting reactant is. We are given grams, so we have to go to moles first. We do our stoichiometry for phosphoric acid here, and then at the end, we're going to get a certain number of grams of phosphoric acid. And I'm going to do all that. But then then the question tells us we actually got, when we did the experiment and weighed it out, this is what we actually got. So what's the percent yield of this reaction? Hockey. So um, let's go through and work this. Take a little drink first. All right. Um, Step one, we need to go through and change these guys to moles right off the bat. So I'm going to work with the phosphorus pentachloride up here, and I'm going to work with the H2O down here. We have 204.07 grams, and we are going to have to take this to moles, so grams over moles. So we need to figure out the molecular weight of this. So we can do that real quick. Molecular weight. And that is 208.24 grams per mole. Double check to make sure that this is actually what we're after. Yes, good. Good, good, good. Where? There we are. It was 208.24. And then we can go through and do this quick calculation. 204.07 divided by 208.24. And we're going to end up with, I'm going to move this over to the other screen so I can see it. 0.97997. This many moles of PCl5. Okay, let's do the same thing with water here. We have 233.96 grams. We have to go from grams to moles. And I know water is 18 grams. Let's go through here. Okay, so 233.96 divided by 18 is 12.997 moles. So we can tell right off the bat, okay, yeah, definitely we have a lot more moles of water. But also remember that we also have to divide these by the coefficients to see which one's going to run out first. And when we do that, just looking at it, I can tell water is going to still be in excess. That potassium pentachloride is going to be our limiting reactant. But let's just double check. .24 moles here. Yeah, so it's bam. This is our limiting reactant. Limiting reactant. Bam. All right. And since we've already calculated this, I'm just going to hold on to it. 0.97997 moles of potassium Cl5. All right. Put it over there. And what are we trying to get to? We're trying to get to grams of phosphoric acid. Hang on. I'm going to need more room. All right. There we go. We're trying to get to grams of phosphoric acid. Okay. Grams. And what do we do? Well, first thing we need to do is do our stoich step. We already have our moles, so we can do our stoich step. What is that molar ratio going to be? So looking here, it is 1 to 1. Okay? So now, if I were to just calculate this, I would have moles of H3PO4. But I don't want moles of H3PO4. I want grams. So we're dropping moles, picking up grams, and we can look up H3PO4. Molar mass is 97.994. So 97.994. All right. So now we can go through and calculate that. 0.97997 times 1 divided by 1 times 97.994. Boop. And we're left with 96.03 grams of phosphoric acid. So this is what's called a theoretical yield. If everything goes perfect, if the world is all sunshine and rainbows, then we should get exactly 96.031 grams of phosphoric acid. But the world's not that way. Stuff can go wrong. So whenever you go through, this is the perfect score, but you didn't get a perfect score. This is what you got. And so you just find the percentage of this. So when you find a percentage, you take your actual divided by 75.867 divided by your theoretical, and you'll get, and then times it by 100 to get your percentage. So 75.867 divided by 96.031, and then times it by 100, 79.00%. 79.00. Grade it. See what we got. Hooray! We did it. So this is actually pretty useful, because imagine you're like a chemical engineer or something, and your job is to get, you have a specific product that you're after. You're making a certain product, a certain chemical. You want to make sure that this percentage is as close to 100% as possible, right? I mean, if let's say that you do it and get 79%, but then another person who's after your same job can do it for at 84%, um, which one do you think they're going to hire? And being able to calculate this is, just the first step. You need to know how to calculate this before you can even get good at getting this as close to 100 as you can. All right, so that's that. I'm gonna have, um, a small worksheet for you guys. Not many, like I think like 5. It's not gonna be terrible um, for this, and then that'll be it for Wednesday. On Thursday and Friday, I'm gonna have you guys write your own, go through, write your own problems, and then submit those to me by Friday. I'll be around. I won't be around Thursday. I have a dentist appointment, so I'll see you guys. See you guys then. I guess I'll see you guys on Monday. In case you haven't heard, Monday, Tuesday, Wednesday in person. Thursday, Friday distance. Monday after that in person. So there's that. I will see you guys Monday, I guess.